general relativity step by step. Before I get started on this screencast, I want to correct a transcription error which I made. I wrote these nice handwritten equations down, copying from my Maxima script here, and there was a factor of 2 here. See if I can highlight it on its own. Yeah, that I didn't write down correctly. I didn't write it at all. So I'm just going to put that in there. I'm going to pinch in a little bit and write it there. Right, that feels better. Okay, so what am I going to do? I'm going to use these. I'm going to use this form for the Ricci tensor here to solve for A and Q using the Einstein field equations. Einstein field equations, I'm going to refer you back to screencast 155 of the original series, GRSS 155. Okay, so what did we have there? We had this. We had that the Ricci tensor R mu nu was equal to 8 pi g over c to the power 4 t mu nu minus a half g upstairs mu nu stress energy scalar plus cosmological constant times g mu nu. Well, as you can see, the right hand side is quite a complicated thing. It's a combination of stress energy tensor here and stress energy scalar here, and a cosmological term here. And what I want to do is to factorize this expression and bring the two types of terms together so we can solve it more easily and get a handle on what this Q thing and the A thing are, the functions Q and A. So what I'm going to do, I'm going to do that by defining here. I'm going to define a function, a stress energy tensor, mu nu, and V for vacuum. And that's going to be equal to minus cosmological constant g mu nu over this factor here, 8 pi g upon c to the power 4. And the reason I'm doing that is that I want to be able to bring this thing inside that bracket there. So that's why I'm doing this. Let me just pinch in a little tiny bit. What I'm going to do now is to multiply on the left and the right of this equation here. This is a defining equation. That's a definition of this thing here. Better not put that. It looks like a bar. So I want to extract a scalar from this. So what I'm going to do is to multiply on the left and the right by g mu nu, t mu nu vacuum equals minus cosmological constant over 8 pi g upon c to the power 4, g mu nu upstairs, g mu nu downstairs. And this thing, of course, is a scalar, and its value is 4. So it's, minus 4 over 8 pi g over c to the power 4. And by definition, I'm just going to call that t and then a subscript v for vacuum. V equals vacuum. So we've got some new concepts to play with here. We've got a stress energy scalar here that will allow me to factorize the Einstein field equations, and I've also got a nice new scalar to play with that represents the vacuum. Well, it's the vacuum stress energy scalar. Great. So I can use these things here on my right hand side of my stress energy of the Einstein field equations. So I've got 8 pi g upon c to the power 4 into t upstairs mu nu minus a half g mu nu minus t vacuum mu nu from this equation here. So there it is. Right, and now what I'm going to do is to write that out in a slightly different form as follows. It's going to be 8 pi g upon c to the power 4 t mu nu plus t vacuum mu nu minus a half g mu nu minus t I'll do it explicitly, plus 4 from here, over 8 pi g upon c to the power 4 g mu nu. Getting a little bit messy there, but there it is. Now then, I'm going to consolidate. It's 8 pi g upon c to the power 4 should be a t there, into t all, that's everything together, mu nu, minus a half g mu nu, just factorising these terms here, t plus t vacuum. Correct by definition, because all I'm doing is using this form here. Took a little bit of time to get my brain around this. Equals 8 pi g over c to the power 4 t, everything together, mu nu, minus a half d mu nu t all, which is these two terms added together. And the left hand side was r mu nu. Okay, so we've got this rather nice equation here, and this is written in a nice form that allows us to solve the Einstein field equations for a particular value of the cosmological constant that we can plug into our thinking, and also for the stress energy tensor, which has got physics in it. It's got things like equations of state, the density of the universe changes as it gets older, we might have radiation pressure, we might have a non-zero pressure term, we could have all sorts of physics, all of which I've got embedded in this stress energy scalar and stress energy tensor here. So I'm going to stop there. Stop.